Well, hello guys, here Mr. G with another video for the grade 12. This time we're going to be solving a question 8 from June 2016 question paper done at the Northern Cape and Free State province. This one is going to be a question about acid and bases, which is a very important topic for the year. Now this question said the table below shows the pH range required in soil for the growth of different crops. And then you have the range of different plants, different crops that need to grow, and that is the pH range for that specific plant to grow, the pH of the soil. Now question 8.1.1, do the above crops need acidic or alkaline soil for growth? Give a reason for your answer. Now you need to remember that the pH scale is going from 0 to 14, in which between 7 and 14 is going to be bases. Between 0 and 7 is going to be acids, and right in 7 is going to be in neutral. Okay, this is the basic pH scale. Alright, that is important. If you look at the pH range for these crops to grow, all of them are less than 7, and therefore this is going to be an acidic soil. So this soil is going to be acidic. Alright, now why is acidic? Because the pH is less than 7. The pH is less than 7. pH range, we're speaking about range. pH range is less than 7. Question 8.1.2. A farmer plants peanuts and radish and find that only the peanuts grow well. We're speaking about the peanuts and the radish. You can see the different soils there. Write down the pH range of the soil in which these crops grow. And they're speaking about the peanuts, which are the ones that grow. If you read the farmer plants and peanuts and radish, but find that only peanuts grow. So the pH range for peanuts, guys, is given in the table. It's between 5.0 to 6. That is the pH that the peanuts need on the soil to be able to grow. Write down the name of another crop that is most likely to grow well in this specific range. And guys, we're talking about between 5 and 6. The other one that you can see here is the mangoes. So the mangoes is the other crop that can grow in that specific soil. All you have to write here is mangoes. There we go. Now question 8.2. Now this table is not needed no more. Question 8.2 said during a titration, 25 cubic centimeter of a 0.1 mole of potassium hydroxide, and just for recall, potassium hydroxide is a strong base. Potassium hydroxide is a strong base. Solution is titrated against a 0.1 mole per cubic decimeter of hydrogen carbonate solution. And you need to know that hydrogen carbonate is a weak base, acid. Right? Hydrogen carbonate is a weak acid. The balance equation for the reaction is, and they give you the balance equation. Define a base in terms of Arrhenius theory. Alright, so what is the definition of a base according to Arrhenius? A base is a substance that produces hydroxide ions. The hydroxide ion, remember, is OH when dissolved in water. Be careful, don't you give the definition of Lowry-Bronsted theory, okay? So now we're going to question 8.2.2. Write down the name of the most suitable indicator for this titration. Choose from BROMOTHYMOL BLUE, PHENOLPHTHALEIN and METHYL ORANGE. Okay, now to answer this question, the first thing I want to do is to recall the pH range for each of them. So BROMOTHYMOL BLUE have a range of 6 to 7.6. So this one is 6 to 7.6. That is for BROMOTHYMOL BLUE. For phenolphthalein we have 8.3 to 10. And for methyl orange, we are going to have 3,1 to 4,4. This is the range of the pH of each of these different indicators. Now, you are going to use the bromothymol blue when you have a strong acid. Let's do it here. When you have a strong acid and strong base. Or alternatively, when you have weak acid and weak base. Why is that so, guys? Because when you have a strong acid and strong base, the salt will have a pH which is around 7. It's close to 7. That is why we use that one there. You can see that the phenolphthalein, it is greater than 7, far greater than 7. So you are going to use this one when you have strong base, plus a weak acid. You can see there that then is acid. Sorry. That's right, the weak acid. It's difficult to write sometimes. Weak acid. Why? If the strong base, you have a strong base and a weak acid, the pH is going to be greater than 7. Alright? And then when I say pH, is the pH of the salt. Okay? pH of salt. For everything here. Now, when the methyl orange, you can see that the range is less than 7, and this one you will use it when you have a strong acid and a weak base. There we go, because the pH is less than 7, pH of the salt. Alright, so guys, this one is the 3 indicators you have to learn with the range. You do not have to learn, okay, you should learn the range, because you see in this question, for instance, you need to know the range to know. However, the important thing is to know when to use which one. So the important part here, guys, is going to be the relation between this side and this side. In other words, bromothymol blue, you use it when you have a strong acid and strong base, or the other way around, weak acid and weak base. Phenolphthalein, you use it when you have a strong base and a weak acid, and a methyl orange is when you have a strong acid and a weak base. The range is not important, but I gave you the range because sometimes you need it, okay? So now the question says, which of these 3 indicators is most suitable for this specific titration? And remember, we have the reaction between a strong base and a weak acid, as you can see on this point here. Therefore, the most suitable one that you are going to use is going to be phenolphthalein. That is the one that will have a pH greater than 7, as you can see here in the table I draw for you. Now, question 8.2.3. What is the purpose of the indicator? Now, be careful. What is the purpose of the indicator in this titration? So what is the idea of the indicator in this titration? It's not a general question of what is the purpose of a indicator. In this case, is the purpose of this indicator in this titration. Guys, that one is to show the end point of titration, or to show when the reaction is being neutralized. So we have to say that is to show the end point, or you can say it is to know when neutralization occurs. Question 8.2.4. Calculate the volume of the acid that will have reacted with the base when the endpoint is reached. So it's using titration, and it's straightforward. We can use the formula of titration. Now, if we go to the formulas here, guys, which I'm going to show you, this is the formula you are going to use for titration. Now, note, this formula can only be used for titration, guys. So they must in the question speak about either neutralization reaction, or they say that during titration, or this acid is being titrated, or things like that. So that one is the formula for titration. Now, here is what we have. That is the balance equation. The question said during the titration, 25 cubic centimeter of a potassium hydroxide with a concentration of 0.1 mole per cubic decimeter. All this is for the base. This one is the base, so it is for base. And all this one here is for the acid. Alright, they said calculate the volume of a hydrogen carbonate that was used. And we are going to use the formula. The formula said that concentration of A, volume A, divided by concentration of B, volume B, is equal to Na divided by Nb. And I want you to note that this one here, guys, this one here is for the ratio. Alright, so let's call the acid to be H2CO3 is going to be A and KOH is going to be B in this equation. And now something else very important, in this formula you do not have to convert the unit. You can work in centimeter cubic as long as everything is in cubic centimeter. So the concentration of the acid is 0,1 multiplied by the volume of the acid, that is what you are actually looking for, divided by concentration of the base is 0,1 multiplied by the volume of the base, which is 25 cubic decimeter. This is equal to N of the acid. It is the numbers at the front. Remember, in this case is a 1 divided by the N, or the ratio of the base, which in this case is 2. And guys, the rest is very easy calculations here. So if you rearrange and you do cross product, is volume of the acid is equal to 0,1 multiplied by 25 multiplied by 1 divided by 0,1 times 2. That is how you solve this one, and you will get that the volume of the acid that was used here or was neutralized is 12,5 cubic centimeters. Note and be careful, we work in centimeter cubic when substituting, therefore the answer is going to be in cubic centimeters. And guys, this is the answer for the volume of the acid. It's very simple. This question is almost done. A farmer take a soil sample to the laboratory to analyze. He accidentally spills 10 cubic centimeter of 0,1 mole per decimeter cubic of hydrogen carbonate solution on the sample. So he actually made the sample more acidic than it was. He then put 13 centimeter cubic of a 0,1 mole per decimeter cubic of potassium hydroxide solution into the sample. Which substance is in excess in the sample? Explain the answer. Okay, now in this question, what is the first thing we do when identifying a limiting reagent? We are going to find the number of mole of each of the substance, and I think we are going to have enough space on this point. So remember, concentration is equal to number of mole divided by volume. This one is given to you, and I'm going to rearrange it, guys, because I want to do the question real fast. The number of mole, when you rearrange it here, is going to be equal to concentration multiplied by the volume. All right, so we're going to do it on one side for the hydrogen carbonate. For instance, on this side is for H2CO3. There we go. You need to convert to decimeter cubic, so this one is going to be equal to 0,01 cubic decimeter. And then when you go to the potassium hydroxide, on this side will be equal to 0,013 cubic decimeter. So we have to calculate the number of mole for each of them. Here, number of mole is equal to the concentration, which is 0,1 multiplied by the volume, which is 0,01. This one is the number of mole of hydrogen carbonate. You get that the number of mole here is 0,001 mole. That is the number of mole that he actually accidentally spilled on the soil. Now for a potassium hydroxide, same formula. This one is for KOH. Same formula. Number of mole is equal to the concentration multiplied by the volume. The concentration is also 0,1 mole, and the volume is going to be 0,013. When you calculate this one, you get that the number of mole is equal to, and this gives you that the number of mole is 0,0013 mole. Now we have a little bit more of this one. However, this one doesn't tell you yet which one is the limiting or the excess reagent. So to do this, guys, we're going to use the ratio of H2CO3 to KOH. If you go to the equation, you can see the ratios are 1:2. Remember, the ratios are the numbers at the front. We just work with those things just now. So it's 1 for the hydrogen carbonate and it's 2, I hope you see the number there, for the potassium hydroxide. So now you are going to use either of the two calculated. It doesn't really matter. Let's use the first one. If you want to use up or neutralize the 0,001 of the hydrogen carbonate, how much of the potassium hydroxide would you need? Then you are going to do cross product here. When you do this calculation, which is very simple, it's double. This case is double, is 1:2, so it's double, but sometimes it's not double. That's why I recommend you to practice how to do it with the cross product. So to neutralize the 0,01 mole of hydrogen carbonate, you will need the double amount, which is 0,002 mole of the potassium hydroxide. However, you don't have that amount, guys. You only have, if you look here, 0,0013. Therefore, the potassium hydroxide is the limiting reagent and the hydrogen carbonate is in excess. And that is the answer for this question, guys. This is the answer for the whole question 8. It's a very good question to practice acid and bases. Most of the things are done from grade 11. However, there's few things that is new to you. But thank you for watching. If you think it helped, thumb up, subscribe for the channel. I'll see you next time. Mr. G here.